Hello, welcome to a video on measures of dispersion. In this video we're going to determine the range for a data set and the standard deviation for a data set. Dispersion is another way to say like the spread, how spread out your data is. So let's get back to range. So the range, all this is basically the gap between the biggest and smallest value. So to find the range, we just simply take the highest data value and subtract the smallest data value. So if we wanted to find the range in temperatures in Honolulu here in this example, 89 minus 61 is 28. So we've got a range of 28, which is just the difference between highest minus smallest. Alright, and then if I have the 5 oldest U.S. presidents, so I'm just looking at these 5, so 69 and 64 for the start of their first term, we want to find the range, 69 minus 64. Okay, easiest statistic to compute. Alright, now we go from the easiest to one that's like 100,000 times harder. The standard deviation, the formula down here that we'll ultimately get to, you can think of it as a formula or you can think of it as this series of steps. Either way, whichever helps you. But the range, we just subtract and we're done. But for the standard deviation, notice we've got, remember that sum symbol right there, and that means we're adding. So we add, and then we've also got subtraction. Alright, and then remember power, squaring, that means multiplication. Alright, and then we've got division, and then we've got square roots, which is like exponents, and the squaring is exponent. So this formula basically has every mathematical operation there is. So we go from one formula that's just simply subtraction to a very complicated math formula. But again, you can think of it as this 6 series of steps, and then it's not so bad. If you think of it that way, it ends up being a pretty doable thing. So the first thing we're going to do with standard deviation is find the mean of a data set. Alright, so you find the mean, and then you subtract the mean from every element in the data set, which is called the deviation. So if you take a measurement, subtract the mean, that's a deviation. Okay, so let's look at our president's example. So we've got those 5 oldest presidents when they started their first term, 69 to 64. And we find the mean of that, that's 66. Okay, that would have been step 1. Okay, and then after we got step 1 done, step 2 was take that mean that we just came up with and subtract that mean from every data point. So we take that 66 and we subtract it from every single data point that we have here. Okay, and it's perfectly fine if, like for these last 3 here, if that goes down into the negative, that's perfectly fine. And what you should also notice is that if I add these together, the deviations, okay, our step 2, the deviations should always sum to 0. So notice 3 plus 2 is 5, 5 minus 1 is 4, minus 2 is 2, minus 2 is 0. They'll always sum to 0. Alright, so that's the deviations. Okay, 3, 2, negative 1, negative 2, negative 2. Alright, what do we do after that? We're going to square each one of these deviations. So after we have subtracted the mean from each data item, because they always sum to 0 because of those negatives, to help deal with that, we square the data items minus the mean, so we end up with a positive value. So if I take those things that we've done, we found the mean, we subtracted the mean to get the deviations. If I now square each one of those deviations, 3 squared is 9, 2 squared is 4, and then those negatives, when I square those, I get positives. So everything's positives. So I've squared the deviations. Now back to this. I'm going to add all the squared deviations. Okay, that's where the little sum formula comes from. I'm going to add all the squared deviations. And then I'm going to finally divide those squared deviations by 1 less than the sample size. So here the sample size was 5, so I subtract 1 from that, and I get a 4, and I get that 5.5. Alright, this step, even though we didn't give it a name on this slide right here, when you are at this step before you've taken the square root, this is called the variance in the data set. So V-A-R-I-E-N-C-E. Alright, and then if you take the square root of the variance, that is the standard deviation. So we take the square root of that 5.5, we get 2.35, and that is the square root of the variance, the square root of that sum of the square deviations. So right here, when we squared everything, divide that after we've done that step. Divide by, there were 5 measurements, 1, 2, 3, 4, 5. We're dividing by 1 less than that. Alright, and then that's where that 4 is coming from. Then take the square root of that number, and there's your standard deviation. Alright, now in the next video, just like we did a lesson with Excel, doing measures of center, we're also going to use Excel for measures of dispersion or measures of spread. And we'll look at how Excel can help us with the range and the standard deviation.